limit extending to 0 plus, okay, the f dash x is equal to limit extending to 0 plus derivative of sin x is nothing but cos x. So what we get, limit h tending to 0 cos of 0 plus h, which will give you 1. Now limit extending to 0 minus f dash x, which is equal to limit extending to 0 minus derivative 1 is 0. So what we see is left hand derivative is not equal to right hand derivative. Therefore, function is not differentiable at x equal to 0. So now I give an idea how the graph it look like and what they mean. This is, we have to take up to pi by 2. This is 0. Next from 0 it is a straight line. It's not complete graph. It is showing the graph as complete graph. This is the graph. So this is the graph. Okay, what we observe, here slope is 0 and here slope is 1. So left hand slope if I write is equal to 0 and right hand slope is equal to 1 about the 0. So clearly I'll draw once again to make you more understandable. So it is like this. Okay, so this is equal to pi by 2 and this is equal to 0, and further whenever x is less than 0, the slope is 0. At x equal to 0 from right, the slope is equal to 1. This angle is equal to pi by 4. So that is the reason whenever the sharp edge is there, function is not differentiable at this point. So this point is 0. So the value is 0, 1. So function is not differentiable at x equal to 0. This is a sin x graph, but we have to take from 0 to pi by 2 only. This is x is less than 0. The slope is 0 because it's a straight line, y equal to 1. 0 to pi by 2, it goes up. I can show you also once again. So right hand derivative is equal to 1, left hand derivative is equal to 0. Therefore, left hand derivative is not equal to right hand derivative. The function is not differentiable at x equal to 0.